Welcome protein coders, let's build some coding muscles. Today we're going to solve a problem, house robber. So what this problem says is, you are a robber and you have to rob few houses which are in a row. Okay, and every house has some value and you want to rob the maximum value from all the houses. But there is a catch, you can't rob any two houses which are adjacent because there is a security alarm which will ring if you rob any two adjacent houses. Okay, so here in the example, let's see, in the first example you have 1 2 3 1. So the maximum value you can rob is first element and the third element. Okay, similarly in the second example you can rob first, third and the fifth element. Okay, so the total robbing value will be 12. Now let's see this question, how are we going to solve this. So let's say I have these 6 houses in a row. Okay, and I picked the last house to rob. Okay, I robbed this house. Then according to the question, I can't rob from the adjacent house. Okay, I can't pick this up. And from the rest of the houses, what I want the maximum rob value possible till index 3, right? So my function will be, it will take the index and the nums value. My function will represent the maximum sum possible till the given index, from 0 to the given index. Similarly, I will have another case, if I don't pick the element at index 5, then I want maximum possible sum till index 4. These are two cases I have, right? If I rob or if I skip. And at the end, I will take the maximum of these two cases. Okay, so let's write a recursive code based on our observation. So we will have a function. Okay, it will take the index and a vector nums. First case will be if I pick the element. Okay, if I pick the house to rob. So in rob will be the value at that house plus the maximum value till index idx minus 2. Okay, and other case is the skip case. If I skip the house, then I will simply get the recursive call for the idx minus 1, and at the end I will return the maximum of both cases. For the base case, suppose if I reach the house at index 0, okay, in that case I only have one option, so I will pick the house, right? So I will return nums of 0 idx, or nums of 0 also you can write. And there is one more edge case. If you observe, we have also called for idx minus 2. So if idx becomes 1 or 0, it will give us negative value. So for negative values of indices, we will just simply return 0. Okay, so this is a recursive code. And of course, for every edge case, we are calling 2 recursive calls. So it will be of exponential time complexity, right? 2 to the power n. That's why we will use memoization, right? In memoization, we will just modify our recursive code a little bit. We will pass a dp vector and it will be a 1D vector because we only have one variable index here. Okay, so it will be a 1D vector. And at the end, we will store the subproblem value in the dp vector, and finally we will check if dp of idx is not equals to minus 1, we will return dp of idx. First thing is passing a dp vector whose dimension will be based on the input variables, and we are storing the value of subproblems and a early return if subproblem is already solved. So this is our memoization. Here time complexity became order of n. Now let's see the tabulation code, how we modify this memoization code into tabulation. So tabulation, let's write our function. It will take argument the vector nums. Okay, first let's get the size of the vector, and suppose if we have no elements, if n is equals to 0, we will return 0, or if we have one element, we will return nums of 0. Okay, these are the edge cases. Now let's create the dp vector similar to memoization. Okay, and for first case, if we have only one house, then we will store dp of 0 is nums of 0. If we have two houses, for this case dp of 1 will be maximum of both the houses, right? And then for our for loop, we will take the help from the recurrence relation which we have in our memoization. We will run the loop from 2 to n, and our dp of I will be equals to what? Maximum of rob condition and skip condition. For rob we will have nums of I plus dp of I minus 2, and for skip we will simply have dp of I minus 2, right? This is the rob condition, this is a skip condition, very similar to our recurrence relation. And at the end we will return dp of n minus 1. The answer will be stored in the last element of the db vector. Okay, so this is a tabulation code. And for the time complexity, the recursion is exponential, memoization is order of n. Similarly, tabulation will also be of order of n because we are running a for loop. Okay, from 2 to n. Now, if you observe in the code also, our dp of I value is dependent on the dp of I minus 1 and dp of I minus 2, right? For every dpi, for every element, I am dependent only on the previous two values. So I again no need to maintain the complete vector, right? We can only maintain two previous values. So let's do that and write our space optimized code. So there is a small trick just for help. In our tabulation code only, what we can do is for dp of I minus 1, we will write it as previous, and whenever we get a dp of I minus 2, we will write it as previous 1. Okay, and for dp of I we will write current. Okay, so let's modify our tabulation code. So let's define our previous and previous 2. Previous 2 is the previous of the previous value. Also let's do the changes in the for loop. Wherever we have dp of I minus 2, we will replace it with previous 2, and dp of I minus 1 with previous, and dp of I with current. We will define a current variable also. So we will just maintain 3 variables. And after this, we will push the previous values one step ahead. Previous 2 will become previous and previous will become current. And at the end, we will return the previous value. Okay, very similar to the Fibonacci question which we have done earlier. The time complexity here for the space optimized solution will be similar to the tabulation memoization, but the space complexity reduced down to order of 1, constant space time, because we are only maintaining 3 variables. So that's a space optimized solution, right? Now let's revise what we have studied today. We have seen the house robber problem, in which we have a constant, we can't take the adjacent houses, right? We see 2 conditions, skip and rob, right? Then we write the recursive code for that. Then we saw the memoized code for that. Then we saw how to convert the memoized code into the tabulation code. Right? We saw the base cases, how we write the base case. And finally, we observe that every value is dependent on the previous 2 calculated values. So we wrote the space optimized solution. So that's all from my side, guys. You will find the problem and the complete solution code link into the description box. I will urge you to solve this problem by yourself first. If you have any queries, please mention them into the comment box. I hope this helps. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.